Hello everyone. Here is another session of analytical geometry revision. You have one question with 6 subdivisions. Watch carefully, enjoy the video. Thank you. Question 1. In the diagram below, we have P, Q and R. The equations of the sides PR and QR available. Equation of PR is y equal to minus x plus 2 and equation of QR is x plus 3y plus 6 equal to 0. Now determine the gradient of PQ. We know the gradient formula. It's available on the information sheet or formula sheet. You don't have to memorize any formula. Just refer your formula sheet always. Here the formula for the gradient is m equal to y2 minus y1 over x2 minus x1. We have the coordinates of P 1, Q 0 minus 2. Substitute y2 minus y1, that is minus 2 minus 1, divided by x2 minus x1, that is 0 minus 1, which is simplified on the calculator. You don't need to guess anything, and the answer is positive 3. So the gradient of PQ is equal to 3. (1.2) Prove that angle PQR is equal to 90 degree. We have the equation of QR, that is x plus 3y plus 6 equal to 0. From there we get 3y equal to minus x minus 6, or y equal to minus 1 over 3x minus 2, in the form of y equal to mx plus c, where m is the gradient. M of QR is equal to minus 1 over 3. We already have the gradient of PQ in the previous question, that is gradient of PQ equal to 3. Now our question is to prove angle PQR equal to 90 degree, and we have the properties. The gradients of the perpendicular lines make product equal to minus 1. We use that information here. MPQ times MQR is equal to 3 times minus 1 over 3 equal to minus 1. So what we understand is angle PQR is equal to 90 degrees. Question 1.3. Determine the coordinates of R. We can see that R is a point of intersection of the two lines PR and QR. We have the equations of PR and QR. So we have to solve these two equations simultaneously. X plus 3y plus 6 equal to 0 and y equal to minus x plus 2, where we substitute y equal to minus x plus 2 into the first equation. We get x plus 3 times minus x plus 2 plus 6 equal to 0. Removing the bracket, simplifying the equation, we get x equal to 6. Now the x-coordinate of R is 6. Then we choose the simplest equation there, that is y equal to minus x plus 2, and substitute x equal to 6. We get the y coordinate equal to minus 4. Thus we have the coordinates of R, 6 minus 4. Next question, 1.4. Calculate the length of PR. Leave your answer in third form. Length of PR. Of course, we use the distance formula. We have P11 and R 6 minus 4 from the previous question. Therefore, the length of PR using the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. We substitute P and R, or the coordinates of P and R. We get PR equal to root of 50, which is simplified to 5 root 2 in the form of a third. Question 1.5. Determine the equation of a circle passing through P, Q and R in the form x minus a whole square plus y minus b whole square is equal to r square. We learned circles in grade 12. PR, of course, PR is a diameter. Now PR is root of 50 from the previous question. Therefore, radius is half of the diameter, which is root 50 over 2. R square is equal to 50 over 4. And the center of the circle, we use P and R using the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2, that is 1 plus 6 over 2, and 1 minus 4 over 2. So we have the x coordinate and the y coordinate of the center, that is 7 over 2 and minus 3 over 2. Now we use this center and r square to write down the equation of the circle, that is x minus 7 over 2 square plus y plus 3 over 2 whole square equal to 50 over 4. That is the equation of the circle at center A, B and radius R. So you can have the equation there. Question 1.6. Determine the equation of a tangent to the circle in the form y equal to mx plus c. We know that tangent is a straight line. We learned equation of circle and equation of tangent in grade 12. So since it is a straight line, we need the gradient and at least one point on the line. We have now the equation of the diameter PR, that is y equal to minus x plus 2. Therefore, the gradient of the radius or gradient of the diameter is minus 1. Now the tangent is always perpendicular to the radius. Using the property of the perpendicular lines, we know that the gradient of the tangent can be obtained by dividing minus 1 by the gradient of the radius, that is another minus 1. So minus 1 divided by minus 1 gives us positive 1. The gradient of the tangent is positive 1, and the tangent is passing through the point P11. We use the formula for the straight line, that is y minus y1 equal to m times x minus x1. We substitute m, we substitute the point P11, and we simplify, get the equation y equal to x. Of course, here the value of c, the y-intercept is 0, so our answer is y equal to x. So that is part 1 of analytical geometry. You will see more videos on my channel. Please subscribe my channel. Thank you.